Hello. In the last video, we talked about the power rule among some other rules for differentiating functions, and though I do regret it being a little bit tacked on at the end, I think maybe I can make up for that a little bit by providing some more examples of how to use it. So I'm gonna make up a series of functions, and we're gonna use the power rule to find their derivatives. So how about f of x is equal to -5 over x plus 2x minus 1, I'm not doing this in any particular power order, plus 5x cubed. So how would we use the power rule to find its derivative, f prime of x? Well, so what does the power rule teach us? The power rule teaches us that we can find the derivative of a function with some variable to some power by looking at what power that's raised to and turning, kind of manipulating that power into a coefficient. Specifically, and I can write this out again, let's just write it here. Power rule. We know that if f of x is equal to x to the n, f prime of x is equal to nx to the n minus 1. So how can we use that here? Well, first I want to kind of get all of these into this form here. So x to some power. And we can leave coefficients in. As we also learned in the last video, those coefficients can just be pulled out of the derivative. They're, the derivative doesn't change that coefficient. So f of x is going to be equal to -5 times, well, what's 1 over x? That's x to the negative first power plus 2x to the first power minus 1 times x to the 0th power, right? That would be 1 times 1 plus 5x to the third. So I can basically take the separate derivatives of each of these little parts of the function that I have here, but there's no need to separate that out visually since I think that that's sort of clear. So with this one, as we take the derivative here, we multiply times -1, so that's going to be +5, and then we raise x to the -1 minus 1 power. So that's x to the -2 power. So that would be -1 times -5 times x to the -2 power plus, we're going to bring this over, right? 1 times this whole expression. 1 times 2, the 2 stays in there. 1 times 2 times x to the 1 minus 1. That's just going to be 0, right? So 1 times 2, 1 to the 1 minus 1, x to the 0 is going to be multiplied by 1. And we're subtracting. All right, how do we do this? Well, we're going to multiply out by the exponent. That's 0. So this thing is just going to disappear, right? We don't even have to care about that. So just this constant here, when you're taking the derivative of a constant, is just going to be 0. So 5x cubed now, we pull the 3 over. This is going to be 3 times 5. I might as well be consistent with my use of parentheses. Times 5 times x to the 3 minus 2, right? We have to subtract to the 1 there. I gave away the answer. That's going to be times x squared. All right, we can simplify this further. This first term is going to be 5x to the -2nd power plus 2 plus 15x squared. And if we want to simplify this even further, or at least just get rid of the negative exponent, we could always say that the derivative is 5 over x squared plus 15x squared plus 2, or in what order we want. I don't think it matters that much, but that's the derivative of our function f of x. In a moment, we'll be getting into another example.